Welcome everyone to this exciting episode 2 of Enabling Open Science through Research Code series. This is a partnership between RSSC Africa and RSC Asia. And episode 2 focuses on enabling reproducibility through research code. We are very excited to have you all here, and we have a staggering 194 registrations for this episode so far, which is very exciting to learn. In this episode, we will be having 3 speakers. For this episode, we do have Kozo, Peter, and Radovan. I am facilitating this episode along with Analda and Jyoti. A bit about myself. My name is Saranjeet. I am the co-founder of RSC Asia. We had a very wonderful kickoff episode last month, which was on the third International RSC Day. And we're taking the energy from there and moving on with our series. I would now like to invite Anelda to give an overview and a small recap of what we did in episode 1. There are also resources like blogs, a blog and a recording available if you want to watch that episode, but I'll hand it to Anelda to give a brief overview.
Thanks, Ranjit, and welcome to everyone. It's really fantastic to see so many people in the room today. I hope you're going to have a wonderful experience and that you'll also be able to share some of your own experiences and find that the conversations that we're going to be having will be relatable and insightful and useful to you. My name is Analda van der Walt. I'm based in South Africa. I'm the founding director of Telarify, which is a South African consulting and training company. We develop training programs to assist researchers to grow their digital and computational skills across all disciplines. And also, we're also involved in communities of practice, and we support the RSSC Africa community specifically. So as Saranjeet was saying, we have run our first episode already. In that episode, what we did was really to introduce people to a number of researchers who code across different disciplines. We spoke a little bit about what their day looks like, how much do they code, what their favorite tools are, how did they get into that role? Because I think one of the reasons why we're running this series is because there are so many researchers who spend a lot of time coding, but they are often isolated and don't have communities where they can share experiences, get help, learn about best practices or tools or useful methodologies to improve their work or even just to survive the day. So that's why we're really, really, really excited to have so many people in the room. And we hope that this series will be a starting point for more conversations. We've been running RSSC Africa community meetups and RSE Asia community meetups with Saranjeet and Jyoti in the past. And what we constantly come across is a need for training. Now, what we can tell you is that we can't offer you training in these sessions, but what we hope to do is to introduce you to places where you can get access to training, to open educational resources, and to learning communities, which you can plug in regardless of where you are, more in an asynchronous way, but also through synchronous collaboration and meetup. So that's what we're hoping to give you here. And also to learn more about your needs, to see how can RSSC Africa and RSE Asia and other research software engineering and research software computing environments and communities support our communities. So this is a collaboration between RSE Asia, RSSC Africa, Telarify, the African Reproducibility Network, and the Research Software Alliance. And so you can see that we bring together a bunch of people who have knowledge of resources, opportunities, funding opportunities, and much, much more. And we hope to share that with you and make that more accessible.
Thank you, Anelda. We have 3 wonderful speakers joining us today. In no particular order, we have Kozo, who's joining us from Japan. We have Peter and we have Radovan. So we have a whole range of people joining from different time zones. I think from Wednesday to Thursday. Some people are still in Wednesday. But let me invite Kozo Nikshida, to talk a bit about themselves. Where are you based? What do you do? I'll also paste the questions in the chat so that it's easier for you to refer to the questions and provide us your background.
I'm Kozo Nishida. I live in Japan. I studied bioinformatics at a Japanese graduate university called NIST. NIST is an abbreviation of Nara Institute of Science and Technology. But it was a long, long time ago. It is from 2006 to 2011. And 2011, I joined a research institute called RIKEN, where I spent 11 years studying about the development of computational infrastructure necessary for systems biology research. After that, I moved to my current institution, TUAT. And now I'm working on the development of computational infrastructure for metabolomics research. That's all.
Thanks, Kozo. I think most of us know you a lot from the carpentries community in Japan and have heard about you from there and seen your work in that community. So thank you for your work. Next up is Peter Van Houston. Peter, did you want to share a bit about yourself?
Hi everybody. So I'm in Cape Town, South Africa. I studied at the University of Cape Town many years ago, doing undergraduate degree in computer science. And then from there, I moved on to developing computing and scientific computing infrastructure, first at University of Cape Town and then the University of the Western Cape, which is where I currently am based. And it's at UWC where I discovered bioinformatics and basically learned by osmosis, eventually shifting into my current role where I'm particularly working on pathogen bioinformatics. I have contributed to the carpentries in the past, but sadly not as much as I want to in recent years. And I've just recently started, I will be starting next year to do a master's in public health. I'm very interested in the application of bioinformatics and sequence analysis for public health. So, yeah, but in the last decade and a half, I've been happy to see and participate in the growth of reproducible research in bioinformatics. The emergence of scientific workflows as a major thing that people are using, and the massive increase in accessibility of bioinformatics that projects like Galaxy and systems like scientific workflow systems have facilitated.
Thanks, Peter. It's so nice to see so much bioinformatics expertise on this call. Next up, Radovan.
Yeah, hi everybody. I would like to say thanks so much to RSSC Africa and RSC Asia for having me here. So nice to see you all, and it's so cool to be part of these community meetups. So my name is Radovan Bast. So originally my background is chemistry, computational chemistry. I studied chemistry 20 years ago in Germany, in France. I did some research work in France and in Sweden. But really for the last 8 years, I'm based in Norway, in the north of Norway. So right now it's the dark period. Actually, at this moment, I'm calling from in the middle of the Pacific for work unrelated reasons. Now, what is the title of my current role? It's senior engineer, but I really self-identify as research software engineer. This is really what I do. This is how I see my work. And then give a one-sentence summary of what you do in this role. So what I do these days is I work on the Code Refinery project, and I see there is one of my Code Refinery colleagues here also in the audience, Diana, where we teach really in the carpentry style, but it's more like intermediate level Git, GitHub, reproducibility, modular code development, how to document code, how to test code, like everything that students and researchers need to write reusable code. I also help, I really enjoy helping students and researchers with everything about computing and everything about programming. And I really enjoy working on this interface between programming, computing, and research. That's the area which I enjoy most. And so nice to be here today.
Thanks, Radovan. For the audience, the Code Refinery lessons are the lessons that have inspired this series and the content of this series. Now, after hearing from our speakers from Japan to Hawaii, I would hand over back to Anelda for some polls with the audience and everyone. So, Anelda?
Thanks, Saranjeet. So what discipline do you work in? If you are working in a discipline, or what kind of area do you work in? What kind of organization do you work in? Anything you want to tell us about where you are based and what you are doing there. I'm going to go to the next question. So we would like to know from you, how much of your time, how much of your working time do you spend coding? Is that your main job? Is that just something that you would like to do? Do you still have to get into coding? So kind of none, most of my time, half my time. Just to get a read of the room, what people's experience are with coding. And I saw Kozo already put in our document that he wish he had more time for coding, but mostly spent time communicating.
Actually, a few days per month, to be
Okay.
honest,
Okay.
because I spend more time writing Slack messages and emails than coding.
That's what happens when you've got big collaborations, right?
Yeah. The main reason is the number of organizations and collaborators that I'm involved with. Interacting with many people is helpful for gaining knowledge, but I think it's a problem that I haven't been able to secure enough time for coding.
And I think,
Unfortunately, I
I think,
found the
sorry.
practice for increasing my coding time yet.
I think that's also something that many people will be able to relate to, especially as your career moves up, as you become more mature in your job as well. More time goes towards management and writing grants and less time in coding. But I'm excited to see that we've got a whole lot of coders in the room. My last question for you is, what is your favorite tip for enabling reproducibility? And I think that's what our whole conversation will be about today. So you are welcome to, throughout the session, share these tips, any tools, any products, any setups or hacks that you have that you are aware of, or that you're really excited about using to enable reproducibility in your own research, or that you've seen other people use. And then I think we're going to leave this conversation while it's just getting really exciting, and go back to our panel conversation and hear from our panel members a little bit more about their experience with reproducibility and programming in the research space. So thank you so much for everyone for also participating. As we said when we were advertising these sessions, this is a conversation, and we really, really, really want you to participate, ask questions, share tips, share comments, critique what we are saying. We really are here together to learn and to share what we know. Our first question that we want to ask our speakers is, what is reproducibility and why do you think it's important? And then specifically mentioning examples of times when you encountered analysis that were not reproducible or tools that didn't enable reproducibility. Koza, I see you're unmuted. Would you like to give us your experience and your view on what reproducibility is and why it's important?
To me, reproducibility means that anyone can obtain the same results, no matter who performs the analysis. So I think it is important because without reproducibility, there's no way to prove whether the research is true. So an example of this is quantification of mass spectrometry data in metabolomics. The mass data peaks and annotations and curating the annotations for the peaks still require manual work. As far as I know, the end-to-end workflow automation has not been achieved yet. So reproducing the metabolomics quantification is not possible for now. And we can't determine whether the quantification is truly accurate. So reproducibility is very, very important for metabolomics. I think so.
Thanks, Koza. That's a very interesting example you're giving there. Peter.
Yeah, it's a challenge, right? Because the first thing, why reproducibility? Firstly, because your analysis is seldom one-off. I mean, I'm working on a paper at the moment where moving along and it's analyzing a particular outbreak at the moment, and then more cases showed up. And because this was kind of once off code for a paper, I had to go back and document some of my steps. I said, document everything in the chat, but I didn't follow my own rules. And now that I have documented it and I've made a procedure that we're now sharing between different members of the analysis team, it's going to be easier to add new samples and repeat the analysis. So yeah, so in terms of where I have not been able to reproduce things, in fact, when I got into the field of pathogen bioinformatics, this was one of the things so many papers would mention what they did, but leaving out details. They would mention that they were masking out certain regions of a genome, but not explain like exactly where those regions were. So that made it more difficult for me. It was somewhat intimidating because, coming into the field of Mycobacterium tuberculosis research from a bioinformatics background, especially a computational background, and not knowing any of the biology, then I was constantly asking what to them were probably basic questions. So it led me to write one of my first tools in the MTB research space. I often find that in bioinformatics papers, there can be some crucial little details, especially, with related to, which databases, especially they might have built up a database or something like that they don't include. And this actually inspired one of my first tools in the Mycobacterium tuberculosis space that simply exists to codify what is considered best practice for one particular step of the analysis. So if it's not in code, it very seldom is reproducible, right? So reproducibility to me often means take what you are doing already, but write it in code.
Fantastic. That's also a great example. And I like how you're talking about the fact that you came across this situation also helped you to develop a tool that makes it easier for you and others in the future. Thank you for sharing that. Radwan.
Yes. So what is reproducibility? I really like the definitions that Kozo and Peter gave. maybe I can add a few more things to it. Like when thinking about this question, I was asking myself, what does it mean in practice? Because in theory, it means we get the same result, same data, same analysis, but in practice, it can mean really many things. It's about data, it's about code, script, it's about dependencies, it's about environment, maybe workflows. It can be really so many things. It can feel sometimes intimidating to make things perfectly reproducible. I think it can be difficult. And one thing that I find useful is to sometimes maybe not try to make it perfectly reproducible, but not make the perfect the enemy of the good enough. And I think later also today we will talk about what are some recommendations for like good enough reproducibility. Then why is it important? Because we don't want to lose the time, because we don't want to reinvent the wheel, because we need to validate scientific results. And I also like the question about, can you mention examples when I encountered this? Oh, yes, many times, and most of the time on my own code and publications. So I published something. I wasn't always really aware of why this is important. So when I was doing like my master's PhD, then a couple of years later, somebody comes back, sends an email, and wants to have information about stuff we have published. And then I couldn't find anymore the data, or I couldn't find the scripts, or I couldn't find the intermediate results. But then the other situation where I see that often is picking up something that I did 6 months ago and trying to continue, and then maybe not remembering all the steps. And as Peter said, now these days, since I know that I will not remember anything, I try to document everything, to every single step, because I know that 6 months later, I don't want to start from scratch. Another example where I've encountered this is that there can be a data visualization pipeline. It can be a Jupyter notebook or an RStudio notebook. And I want to update the plots, the images, with new data. And it's nice if I can update them in 5 minutes and don't have to do archaeology and don't have to spend hours or weeks to do archaeology on my external hard drives and figure out what did I do 6 months ago. Maybe one more example, and that is the works on my computer, which can be really frustrating to be in a situation where we run the same thing, the same data, the same analysis with a colleague of mine on different computers, and we get different results. And that can be very worrying if that happens after we publish the paper. And this is a situation that I would like to avoid.
I really like how you and our other speakers are already introducing the sessions that we're planning for December, January, and February. So next month, I'm going to do a shameless plug for next month's session on the 12th of December. We're going to talk exactly about opening up your code. And I think there's a lot of people who are concerned when you say open data, open code. Why must I share my stuff with other people? But exactly that thing, if you set yourself up from the beginning to have your code more accessible to yourself, that already is, in some cases, enough of a benefit to follow some of the good practices in terms of opening up code. So that's the 12th of December. And then on the 23rd of January, we'll be talking about documentation of code and research analysis and all of that. So be your own best collaborator. I see Saranjit is saying in this chat. Exactly. So those are, although we're talking about reproducibility today, it already touches on opening up your code, documentation, and then in the fifth episode in February, we'll be talking about testing and how can you know that your code actually does what you think it does. So it all ties back to the different sessions. But I would like to hand over to Jyoti now to ask our speakers to share some information about the next question. Thank you so much.
Hi all, Jyoti here. I'm really liking the discussion going so far. And the next question for the panelist is, what steps do you take to ensure your code enables reproducibility in your research project, especially when developing code that supports a research article? Kozo, would you like to take the first chance?
Yes, at least I think notebooks like Jupyter Notebook or R Markdown are essential step. Next, we should create packages for the functions in the notebooks so that it can be installed with Python or R package manager for reproducibility. And if you have the time, I recommend creating a dashboard app to run the research workflow using the package. Because with a dashboard app, anyone can reproduce the workflow just by operating a web browser. And it's now very easy to create a dashboard app, especially in Python, using a package called Streamlit. I think it's the best steps for reproduce your research workflow.
I think those are some really nice ideas, Kozo. Peter, would you like to share from your experience what steps do you take to ensure that code enables reproducibility in the research project?
Yeah, so I like the suggestion of notebooks. The one thing that I found though is sometimes having more long running code, and then notebooks don't work so well. So, but so I would say version control, because especially when I am doing analysis when I'm doing code for analysis. In other words, this is not intended for a software product that I will be necessarily sharing, then that code is often evolving. And if there's time pressure, I often will be changing the same code. So having previous versions to go back to in version control is important. The other thing is, and I mean, this is a bit more challenging, is just making sure that you're keeping track of the intermediate data files, because often we are moving from one step of data to the next step of data. So keeping some version of electronic lab notebook. I often use hackmd.io for that, because I can write in Markdown, which is good for documenting code. And then if I'm doing bioinformatics analyses and the tools already exist, then I really appreciate the Galaxy interface, because then my analysis is stored in Galaxy histories. I can go back to it. I can see what I did. Every step is there, and it's super easy to make Galaxy workflows that I share with colleagues. Finally, I will put a link in the chat, but there is a very recent paper on developing improving bioinformatics software quality, because software quality, I think, can contribute to reproducibility. And one of the things it highlights is teamwork. Yes, often I've been talking about individual projects, but elements of teamwork where you are presenting your results to others, I think are very useful in helping you document to others and therefore to yourself what you're doing. And I like this comment about that we are, collaborating with ourselves. We want to be our own best collaborator. One of the reasons that people say we write documentation is to explain to other people, and that other person can be yourself 6 months from now. So I think it's that idea that you must be your own best collaborator can be enhanced by teamwork.
So let's move to you then, Radovan.
Yeah.
Yeah, I'm sure that Peter had one more really, really important sentence to say, but maybe you can write it down. But I like this this idea of collaborating with yourself, with your future self, with your past self. Somewhere I heard that the person that we will collaborate with most in our academic career is my future self and my past self. So let's be kind to my, future self. So what else to add here? What other steps I can recommend? Trying things on a different computer. So meeting up with a colleague or friend, and then whatever I'm trying to do on my computer, we will try on my friend's computer. And then we will realize lots of things that don't work anymore, because then I need to remember what did I install. Then if I'm reading data from /home/bust, we will find out that that doesn't work anymore because my colleague has a different hard drive with different naming. So that can help. There I can also mention a wonderful initiative which is called ReproHacks. Let me put it here on the chat. So ReproHacks is a wonderful idea. I'll put two things on the chat. ReproHack is like a fun thing you can do. You can meet with your colleagues in the same research group, and then I try to reproduce your code example, and you try to reproduce my code example. And it's really instructive, because then you notice all the things that are really hard to reproduce, and then we are still within the same research group. And then imagine somebody from some external person trying to reproduce your analysis. If you work on your own and you don't have a colleague in your research group, you can try to reproduce like an older paper. And because it can be really instructive, it's typically hard. It's then hard to find the data. It's hard to find the code. It's hard to find all of these things, a precise version, but it can be instructive then for your own work. One thing that I posted there on the chat is this JOSS, Journal of Open Source Software, which was also mentioned further up in the chat, which is a wonderful platform on GitHub to publish open source software with open review. What I really like is that they have a nice short checklist for people doing review. And I like to follow the checklist also for my own work, even if I don't publish this work yet. So it's a checklist for like what should it be in the README, what code should be tested, documented, etc. So having a look at the checklist can be really nice. And maybe one more thing that I recommend, and that is to do a little bit of time travel. Like when you look at your project before submitting it, like close your eyes and now imagine, where am I in 3 years? Like, am I still in the same job? Where is my hard drive? This website where I put the data on, or the example, will the website still exist? So try to do a little like mental time travel and imagine, are the dependencies still the same? Will the operating system be still the same? And what I'm here after is that one thing that is important is to make things also persistent and findable. And it means getting a digital object identifier for the data, for the code. There are services like Zenodo, which are wonderful, where you can really in a few steps get a digital object identifier for your script, for your notebook. And then we are sure that it is still there in 5 years. It can still be found, because so many links disappear. They have a half-life. So these are Zenodo.org. Thanks a lot. Now it's on the chat. Yeah.
Thank you, everyone. So I'm quickly going to jump in here with a very, very interesting question that one of our participants asked. Yuvita from, now I have to see again, from Tanzania said, it seems like the suggestions that we are making here is more related to quantitative data analysis. And I wonder if any one of our speakers have experience with working in the qualitative space.
So an example of qualitative research could be where you do interviews to maybe let's say that we want to understand people's knowledge and perceptions around the value of science to them, right? So we're going to go talk to high school students and ask them, what they think a scientist looks like, and so we'll maybe come up with a questionnaire, often a semi-structured questionnaire. Then we're going to record the interviews, and then there's typically a methodology to try and approach all of the interviews the same way, to be consistent in how they get analyzed. But then from within that, you will extract maybe some themes. You will maybe do what's called coding, but not coding like writing Python. You'd maybe note which themes are present in the answers, and then you'd make a matrix of which interviewees mentioned these themes. Just one example of how you could approach it, and then maybe pull out some key statements that people made. So this is a very human activity, but it does relate to me to a challenge that was mentioned earlier by Kozo, where he said that analyzing the data that he deals with is also a very human activity. So how do you, when the human is such a crucial element in the analysis, how do you, so clearly you must keep your data, that's fine, but the actual analysis is a human judgment thing. So how do you make that reproducible so that if Kozo and Radovan and Peter all looked at the same thing, we would all be coming up with at least approximately similar results?
The key is research metadata. I think you already mentioned, Peter, already mentioned it. The data is well described. We might reproduce the analysis, but poor metadata, with poor metadata, we cannot analyze it. So key is metadata. I think we can say it is related with description of the research workflow, and I think it relates to notebook, research notebook, and computational biology.
I think you're hitting the nail on the head there to say that reproducibility isn't only about the code, it is also about the data.
Yeah.
Yeah,
And
thanks.
it's also about sorry, I didn't want to interrupt. I think that was a really good description. I just wanted to add a few things to it, that it's code, the data, it's also about like the steps. Sometimes it might not be possible to codify it, like as Peter said, it's like very like human steps, but then to document them as explicitly as possible. And one more idea there, that in qualitative data, the data itself can be often sensitive, can be personal, might be difficult to share, might be big. What I would find useful if I tried, for me to reproduce the work, would be if I could find example data. So one could produce, so maybe like the real sensitive data cannot be published for reasons, but I would find it very useful to find, it can be synthetic, but like example data an example interview, and then to find as explicit as possible, like a recipe of, so first I did that, then I did this, then I did this kind of data cleaning, and at the end I arrived at this kind of analysis. I would find that useful.
Thanks, Radvan. So there's a lot of comments and questions in the chat, and I thank everyone who's contributing there. We'll get back to some of them now. I do want to ask Jyoti to take us to the next question, please.
So the next question for the panel is, it's not always easy to start from scratch. Why and how can you embark on a journey of reproducibility using other researchers' code?
Yeah. As a reason, I think it is because it leads to improving the entire research industry, not only for me, not only for you. If the reproducibility is improved, it could be reused not only by our own research group, but also by many other researchers. And I think the best way to improve reproducibility is to join communities that are trying to find the best practices for reproducibility, like this community. I think the best community for bioinformatics would be Bioconductor. Bioconductor is a R package repository and community for bioinformatics.
Yeah, I really like the mentioning that it's about community and about working together and learning from each other. I really like that. And so why don't we want to start from scratch every single time? Because we might not have the time. Like in a master thesis, maybe I have half a year to get this done. If we all start from zero, we will. I think the ideal case is that we stand on the shoulders of others, of the previous students, previous PhD students, previous postdocs. But it can be hard. It can be really hard going into somebody else's project and trying to understand it. It can also take time. But even if I write my own thing from scratch, because I really want to understand it, I still might need to reproduce somebody else's code to validate my code, to validate my results, to validate my analysis. Then how do I embark on a journey when reproducing other people's code? One of the first things I look at is the license. Am I allowed to actually make modifications and later share the code? If there is no license, I might not be allowed to publish my changes then 2 years later. And often there is no license. But then what I then do is to then reach out to the authors and ask them, well, would you like to add a license? This would make it easier for me to make changes and be sure that I don't get locked out of these changes. The other thing that I like to look for are tests. It's nice. So this doesn't really apply for like notebooks, because I think for a notebook is maybe too small to really think about testing. But if it's something bigger than a notebook, I like to, if there are tests inside, because then I have like a safety rail before making any changes to the code. And I would run the test. The test will also tell me what the code is expected to do. And then I go from there. But for like changing the code, I like to have tests available.
Radvan, I'd like to actually disagree with you about the notebooks and tests a little bit.
Yes.
Yes, full on tests you cannot easily do, but I would what I've tried to do is use assert and other tools like that to basically say that at this point this number should equal to that number or something like that, you know. I actually have a problem in a paper that I've written recently, which yeah, I maybe didn't follow the best practices, where I had to go back and try and do archaeology and understand how I got certain numbers from. But so even in small pieces of code, you can just check that this is equal to that if you expect it to be that. But I was talking to colleagues from Makerere University in Uganda recently. I really liked how the supervisors organized their students, that they found the students working in similar areas, and they organized them into cohorts of the senior students and the more junior students, and if there was a postdoc, even a postdoc there, and encouraged them to work together. I really think that there can be a kind of there's many factors why people don't work together. There's jealousies, there's insecurities, and all of those kind of things. But it's not good for our practice, our development as scientists, and our growth as coders. One last thing that I'd like to say is that I don't have great examples now. Thank you very much for that checklist from the Journal of Open Source Software, but ideally every project starts with a template, that you don't have a blank page, that it has a README, it has maybe a test directory to put your tests in, it has some modules already pre-imported that you would use in every project or something like that. And of course, this is all in a Git repository, right? So every project starts with a structure. I personally, when I'm writing a scientific paper, find it very difficult to write from a blank page. What I normally do is I find a similar paper to what I want, and I use their structure. And I think it's the same with code, that we basically say that it needs everything like that. Unfortunately, a lot of what I've found in there in terms of you can find GitHub repository templates. Often it's not designed for us as researchers. So it has some of the features that people as professional software developers want, and it can be a little bit heavyweight. So maybe a homework exercise is to, and we can discuss this in the group on LinkedIn or something like that, is to find templates for starting your scientific analysis project.
Yeah, thank you, Peter, and thanks a lot. Also, I really appreciate the disagreement and that you pointed out that there is definitely a place for asserts in a notebook. Also, thanks for the suggestion about like templates, cookie cutters. I also wanted to very quickly answer the question on, so what if I find code somewhere on the internet, Stack Overflow? So there it's typically an open source license, but with attribution. So I would then make sure that if I copy the code, inside the code indicate where it came from, what changes did I make, or who was the original author. I think with AI-assisted coding, it's more complicated. So tools like ChatGPT, I don't know the answer. There is a whole box of like legal, ethical questions, because it's about like what was the training set? Was the training set open source licenses with attribution? I don't know where people are people really credited who provided data for the training set. I really don't know, and I think in the next months and years we will learn from legal experts. So I don't have a good answer for about the AI assisted coding. Maybe somebody else here in the call has.
Thanks so much. Yeah, I think I was reading a news article. Oh, it's a newsletter. And it was saying that it had a graph showing, for those of you in the audience who are familiar with Stack Overflow, with the downward trend of people using Stack Overflow to ask questions around any programming and things that they're struggling with, error messages and so on, and how ChatGPT has really taken over that space. And it will be interesting to see what this space where we get help also evolves. So just out of curiosity in the audience, thumbs up, thumbs down, do you use ChatGPT to help you with your coding? I certainly do. And I find it very friendly and helpful mostly, except when it makes errors. So if you don't use ChatGPT yet to help you with coding, we can definitely also point to some resources that can help you just get easy access to getting started with that. So thank you so much to all our speakers for this very, very useful conversation. I'm also seeing some questions in the audience, in the chat. There's questions about longitudinal data. What I want to say is, if we are not answering your question here, as we said, this is a conversation starter, and we don't expect that we will be able to answer all questions. But what we are doing is we are capturing the questions, and we can go and ask it to our networks. And we've got big networks. So if you have any questions and you don't think we're capable of answering it, or you haven't heard the answer that you're looking for yet, please do feel free to ask it in the chat or on the shared document, and we will definitely try and help you find an answer to your questions or some starting points or pointers. So moving to containers, what do you do to make your not only your code reproducible in your data, but also to be able to share that in a way that, as you were saying, Radovan and Koza, you were talking about using other people's computers. Saranjeet was also pointing out to regularly restarting her IDE to make sure that what is installed and what is loaded. Do you use containers or other environment managers to manage your package versions, your dependencies, and so on? Yes, no, and why, and what alternatives are there? So, Koza, I see you unmuted. Shall we start with you again?
The short answer is yes, but I don't always use containers because I think everyone can easily use it. It requires advanced Linux knowledge. So sometimes I just use pip requirements.txt file only. That's all.
Thanks. Yes, there is a time and a place for containers. Peter?
So so two things. Firstly, I actually very seldom write my own containers from scratch because I work in bioinformatics, and if you write a bioconda package, then that it automatically creates a container both with Docker and in the biocontainers project and with Aptainer. So there's this amazing infrastructure behind the scenes that does it for you if you package your software in a bioconda. And then in terms of using containers, modern workflow systems, Galaxy, Nextflow, SnakeMake, all have the ability to use software that is in containers. And it takes away the problem of takes away two problems. Firstly, it takes away the problem of installing the software, but it also takes away the other problem with containers, which is that, and I think what Koza mentioned, is that containers are not easy to use. You have to run this complicated kind of command where you're mounting file systems and doing all sorts of other things. It's easier with Aptainer, otherwise known as Singularity, than with Docker, but still it's not easy. So the workflow management systems, they hide all that complexity for you. There is one piece of software that for the command line called Bulker that tries to do the same thing. But I must admit, I found it a little bit difficult to use. I'm just adding the link, but I'm not saying this is my recommendation for it. If it worked nicely, it would be very great, that we could just say, use SAM tools, and it would go figure out how to use SAM tools for you or something like that. Yeah, so containers, I think that making things in containers is great for reproducibility. It's a fundamental technology, but it's nice to have something to make the container universe easier for us to use. One amazing success story, at least for me, in terms of containers, though, was that I knew I had to teach a workshop to a group of users that coming from countries with very poor internet, and the workshop itself was being held in Addis Ababa, where the internet is not always the best. The fact that we could use Docker containers meant that I could download about 12 gigs worth of software, put it on USB sticks. So I kind of freeze it using the Docker save command, put it on USB sticks, show up in Addis Ababa, and have everybody load the software with Docker load from USB sticks. And they all had, within a day and a half, we went from 0 to everybody having the analysis pipeline running on their laptops, which I think with hand installation of software and all of that would have been much more challenging.
And that's, Peter, something important that you're mentioning there is kind of workflow, capturing the steps in a workflow. It's also one of the things that you pointed to that you would be interested to chat about is how do you capture all these steps in a workflow, especially, I think what I've seen from many researchers is when you embark on an analysis journey, you don't realize how many steps there are. People are always talking about the analysis and then the visualization. But to get to a point where you can actually analyze your data can often be many steps and a lot of playing around with different tools, playing around with different parameters. Yeah, you've been mentioning some of the workflow engines as well, and I appreciate that. Do you have anything else maybe to add just about workflow engines specifically?
So workflows again are a bit of a investment. Ad hoc analysis, I tend to use, by the way, a package managed like Conda a lot more than I use. So most of my projects, I have a Conda environment for that analysis. But where workflow engines really help is when you want to scale up your reproducibility. When you are doing more than a small number of samples. So, for instance, a colleague of mine is wanting to analyze the docking of thousands of compounds, and the first version that he wrote basically ran the first step of the analysis and saved the intermediate files from there, times several thousand, and then picked up those 1,000 files and ran the second step of the analysis. And now we've got, let's say, 2,000 files, and so on and so forth. So it was a mess. I advised him that when he was working on that scale, he should write a workflow, because then it will manage all of those files for you. It is more difficult when you are doing the smaller analyses. But yeah, so workflows, but then as I said, also Conda environments. And the equivalent, if you're working just in Python, is something called virtual env for just Python packages, and renv for which can be plugged into RStudio for R. But so something to keep whatever you're doing, even if you're not using a workflow system formally, keep all of your dependencies together in some way that you can specify them in a file.
I think that's great advice. Thank you very much. And we are sharing links for everything that's being referred to as fast as possible. If we've missed out anything, you're welcome to let us know. Radovan, what is your experience with containers and workflow engines? Do you use them?
Yes, absolutely. So containers are wonderful, but creating an image can be non-trivial. One scenario which has worked really well for us at my home institution is that when I work with a researcher where I focus on the programming and the researcher focuses more on the application, then I can be the one writing the container, creating the image, and then I just send the image over. And for the researcher, it's much easier than to install it, because if they know how to run one container, they can run any container. So this has worked well with us. For us, so I use Obtainer, Singularity, because typically working on computers with many users. I like to use containers as like a time capsule. If I need to create a time capsule that should still work in 2-3 years. And I like the example on the chat where a code from, what is it, from like the last century still runs, because it's in a container. So that's cool. Containers are great for reproducibility. Creating reusable containers can be hard. Another aspect that I like about containers is that it forces me to document everything, all the dependencies. Like, I cannot cheat, because I have to be explicit about everything. So even if you don't want to use the container, just creating it and creating the image and documenting everything can also be a good exercise, but it can take time. I use sometimes container is too much, but I think all the technologies were already mentioned. The different like virtual env and conda environments and renv. If I can summarize it in one sentence, like something that I know now that I wish I knew earlier was like, if I meet you somewhere on the street and I ask you what dependencies are you using in a project, I think you should be able to answer it with a file. And the file can be, I don't know, requirements.txt or readme or environment.yaml. So make sure that you can answer that question with a file, and not just don't just install dependencies until it works, and because then you don't remember anymore, what did I do? Install them from a file. This is something I wish I did 10 years ago.
That is such good advice, and I can so relate with. I recently had to reinstall my Ubuntu on my laptop. Yeah, it's gonna take a while for me to get back to where I was before, because everything isn't documented. So I think that's also one of the things that I really appreciate in these conversations, is that we are comfortable to say the things that we are having trouble with, things that we are doing wrong ourselves. And I think that's also why we decided to run this series of conversations and not as presentations by experts. We all have our expertise, but we all are also on a journey. And there are like not solutions to everything yet. And that is why we need everyone in this room to contribute to the conversation, to also say what is hard to do, where do we still need investment by funders to help us develop tools and practices that makes research more reproducible. What are the blocks that we find in our road to adopting reproducible practices? Because some of the conversations in the chat has also been about how much time does it take extra to be conscious about your decisions to make your research reproducible. And upfront, it can sometimes seem like an investment that's just not going to pay off down the line. But for some of us who have now started to use some of the more easily implementable changes, it really, really, really does pay off. But there's still a lot of work to do in terms of all of these tools, all of these practices. And the more we speak about it, the more we understand where the challenges lie, the better we can motivate for funding and work and recruit people to come up with solutions to these things that are still challenging. So thank you very much for also your honest examples and telling us about your experiences. So we are going to move to the last question, which I hope people are going to enjoy a lot. And I just want to mention that this series was based on some of the lessons that are being developed by Code Refinery, so by Radovan's team. And this lessons, and the reason why we did that was to make sure that after this session, you have a place where you can go to refer to, get some more information about the topics that we are discussing here, And what's also really nice about the code refinery lessons are that they are language agnostic. Many of them are language agnostic, so it doesn't matter what you are using to code in, it should be relatable to you. And also, it's free, it's open, it's published under open licenses. You can use it to teach, you can use it to learn. And there's quite a number of lessons. And Radovan will also share a little bit more about that, but I'm going to hand over to handle the last question.
Yeah. Thanks, Anilda. So the last question that we have for the panel today is that there are numerous sources for learning to help researchers adopt tools and practices that can enable reproducibility of the code and data. Would you like to point our audience to anything specific? Can they contribute to these resources?
I recommend the audience attend a carpentries workshop near you. It is not only a good learning resource, but also an opportunity for networking with other researchers. If there are no workshops near you, I encourage you to contribute to carpentries by becoming one of the instructors and organizing the workshop by yourself. To do so, please join the carpentries community. You can find information on how to get involved on the carpentries website. That's all.
Yeah, so I mentioned Galaxy earlier, and I really recommend anybody in bioinformatics this Galaxy training. Reproducibility, beyond that, all these different things. I must admit, I don't have a single place where I've learned all of these all of these different techniques, but so I've kind of bounced between different blogs and resources and things like that. For bioinformaticians, I recommend this series of blogs about how to use Conda or make recipes for Conda. This is from a blog called I don't know how to pronounce the Mu character, but Ubinfi. So this was a 3-part guide to working with Bioconda and making your packages. And then, of course, as I said earlier, your package, if you're packaged in Bioconda, will then become a container automatically. It'll be very easy to use within other bioinformatics environments.
So I really agree with the speakers. The Galaxy community is wonderful. Carpentries community is wonderful. Highly recommend the Carpentries instructor training. It really opened my eyes and I changed the way I teach. So I wanted to say just very few words about the Code Refinery project, because that's the project that I work on. And I put here into the chat. So we have a portfolio of lessons. It's a Nordic project, so we are funded. We are like 10-ish people from Norway, Sweden, Denmark, Finland. But really all the material is open. So it's all Creative Commons, it's all on GitHub. Please browse these lessons. You can, on each of these, on like top right, you can then edit on GitHub. So then you can, like, please reuse these, change them. Also, if you have ideas of what is missing, you can open up an issue on GitHub. We listen to these. We know that these lessons are not perfect. So we have a portfolio going from like version control, GitHub, but really focusing on collaboration. And then documentation, testing, reproducibility, software licensing, modular code development, Jupyter notebooks. There is a lot more data visualization, containers. But so I think this is I think it's a useful workshop and lessons to go to after the basic carpentry training. we teach it in a similar style, but it can be like a really good second step. You can also join one of our workshops. So we run online workshops twice per year. The next one will be March or April. We just started scheduling it. Anybody can join. And I think in particular for Africa, it should be relatively easy to join because we are relatively similar time zone. A fun concept that you can think about is we have this bring your own classroom concept. So you can bring a group of people to our workshop and you can then together go through exercises as a team. And then, but if you like to co-teach with us, that's fantastic. Please reach out. And if you have also suggestions on how to improve these lessons, we would love to hear. We know that we need to change things to make them more interesting for social sciences, humanities, because they are created by people who typically come from physics and chemistry. So there is an implicit bias, but we really want to open them up to all disciplines and all programming languages. And we would, love to collaborate with you there. And let us know what you think about these lessons. And it's so nice that it was such a nice message a few weeks ago when I learned that some of our lessons were useful in a meetup series. That's the best thing.
That's very exciting. Thank you very much, Radovan. And thank you also for making these lessons available and making them language agnostic. I think for us, that was a very, very big attraction because we have an audience that comes from all disciplines, all career stages, any kind of coding background, sometimes limited coding background as well. So some of those concepts are quite accessible, even if you're not really familiar with coding. So thank you very much for those lessons and the work that you put into that as well. And we hope that people will take it up and use it to teach students, and let us know how things are going, right? So we are getting to the end of our session. It has gone so quickly again. I really want to thank our speakers and our audience for being so interactive, for sharing your experiences, for asking questions. It was really, really insightful, and I trust you have found it valuable. As we mentioned, our next session will be on the 12th of December, again at the same time, so 8:30 UTC. And we do on the website show what time that is in your time zone. And here we will look at how to open up your code, what about software licensing? Can you get your code published? I saw both Radovan and Saranjeet was talking about the Journal of Open Science Software. Good news for South Africans, the Journal of Open Science Software is accredited in South Africa, so you can get your credits or whatever you call it in academia. So that's exciting news. It's acknowledged. It's part of the DOAJ, the Directory of Open Access Journals. So for those of you who are familiar with that, it's a good option. And people are very, very keen to receive more submissions from Africa as well, and from Asia and other underrepresented communities. So let's get our software published. Our speakers next month will be, as I said, people from Nigeria, from the United States, and we have some very, very exciting lineup. One final comment from each of the speakers.
Yeah, I just want to say thanks so much, and let's learn from each other. Let's share also the things that didn't work, that we tried, and I will also try to write down all the links that I didn't manage to put here on the chat into the sheet. And it was so wonderful to be here, part of this meetup.
Thanks a lot. Guys,
Thank you very much. Let's learn from each other too. Thank you very much.
fantastic. Thank you very, very much for joining us all the way from Japan, Peter.
And I particularly want to thank Radovan for staying up at some ridiculous hour to join us and to make us span the world, but also researchers span the world. We are all on a journey. I also thank you to RSC Asia for joining RWC Africa in this. We often are battling not just technical challenges, but also our own fear of, not being good enough and things like that. And I think that this community has been great. I think the inputs have been amazing. And thank you so much for the very, very active chat on the sidebar that I'm looking at here.
Thank you so much. And I think that's the one thing that I got again and again is don't have to go and figure this out on your own. There are plenty of people who would be happy to point you in a direction, invite you into their communities. There's so many communities that you can join on Slack, or even I know in Africa, WhatsApp is quite a thing for community organization. Free and open source books, free and open source learning resources. So please, we don't want you to be alone on this. Reach out, ask for questions, get to know new colleagues, forge collaborations, and we look forward to seeing you in the community. Jyoti, Saranjeet, thank you very much for being co-facilitators, and we'll see you all again next month.